air column at 25 degrees Celsius in a closed tube was set into vibration by a vibrating tuning fork of frequency 520 Hz. Calculates the velocity of sound at 25 degrees Celsius. Calculates the length of the closed tube at the first resonance, neglecting the end correction. The speed of sound in air at 0 degrees Celsius is 300 meter per second. So here we are going to calculate the speed of sound, that's the velocity of sound at 25 degrees Celsius, and then the length. Now we say that the first resonance, that means happen to be when we that is the first resonance has to do with the fundamental frequency where we have um, the closed pipe to be like this. Here we have the lambda. This is the length, and then which is equal to lambda over 4. Yeah. So meaning that lambda is equal to 4 times L. So to calculate this thing now, we're going to first to do that. First thing you do is to get this velocity, the velocity of sound, and we know that the velocity of sound is directly proportional to the square roots of temperature at Kelvin. Velocity of sound is directly proportional to what? Square roots of temperature at Kelvin. Oh, that means at Kelvin temperature. That is to mean that V of sound is directly proportional to this. So if it's that, what it means is that since we have the first temperature of 0, the 0 degree, and this, we have different things, we are going to compare it. If we are comparing this, what we then have will be, let's say V for the 0, V0 for 0 degrees Celsius, and T for the 25 degree Celsius. Then we have our T0 over what? TT. So this temperature should be at Kelvin. So now we have our first temperature. The 0 temperature is then equal to 0 plus, and the second one, it will be that will give us this will give us 8, the other one 7, 8, 9 Kelvin, and the temperature, the speed of sounding at 0, which is so now we can substitute. I think we have everything we need. We don't have this other one, we don't have this, so that's the first thing we're going to look for. So if I bring this thing, I may be looking for the question, the length of the closed pipe. So we can now substitute. We have over what equal to so the next thing we're going to do, I think we'll be needing this one here now. Let's just do it once. Okay, square. What's wrong with this? What is wrong with this calculator, please? So somebody just tell me what is wrong with this calculator. Oh my god. We have divide by, so the square root of that square give us 0.951 equal to, so if we cross over, we'll have, I need to use this piece. We'll have a, in fact, VT will then be divided by 0. So we can also divide it. So what we have is the final velocity here. We have, or we can say that 345 meter per second. That is our velocity when the temperature is 25°C. So the next one we're going to look into now is the length of the I've cleaned this thing. Okay, that is 5 hours. So we know that frequency, or let's say velocity, is always, so now we're neglecting the end correction, so we can just go ahead and do what we have to do. Remember, initially I said that lambda is always 4 times L. So now we can substitute to then be F is equal to 4 times L, that is the length, giving us the velocity. This is L, please. So our frequency now is 1512, and then we have times 4L equal to our velocity, which is 345. Then we can also cross multiply. If we cross multiply this, we'll have 4L is equal to dividing it, we have 345 divided by 512. That will give us 4L is equal to 0.6738. Then L will be equal to 0.6738 divided by 4, which means divided by 4, which is equal to 0.168 meter. That is what we have as our length. Thank you so much for being part of the class. And then I want to I want to read your comments and like and share. If you have not subscribed, do well to subscribe so that you will always enjoy the fun of being here together. Thank you so much.